Let's consider vectors OA and OB, which will be designated as vector A, which starts at O and goes to A, and vector B, which starts at O and goes to B. Well, theta here is the angle between vectors A and B when taken in a counterclockwise direction this way. We say that that angle is positive. Notice the vectors have to be joined tail to tail. Vector representation in 2 dimensions. Here is a drawing of a position vector. When I see the word position vector, I'm always thinking that the tail has to be at the origin here. This is the point 0, 0. That's where we start a position vector. Well, the position vector of point P, which is right here at the end of this vector A, which is also equal to OP, has the coordinates of x, y. Of course, we go over x and up y. There's our old-fashioned Cartesian coordinates. And also, vector A can be expressed as a column vector. I can say that vector A is go over this much in the x direction and go up this much in the y direction. This A, vector A equals the column vector xy, is the position vector of OP, where P has these coordinates x, y. The key with a position vector, this is the most important thing, position vectors start at 0, 0. And the coordinates from our Cartesian coordinates also tell you where you have to go in terms of go in the horizontal direction this much, in the vertical direction that much. Let's now talk about unit vectors. The most important thing about unit vectors is that they have a magnitude of 1 unit. We've got, in 2 dimensions, 2 types of unit vectors. In the x direction, we have unit vectors designated by I. A unit vector I says go over in the x direction 0, 1 and up 0. A unit vector J says go up. Well, go 0 to the right or left and then go up 1 unit. This here, unit vector I, which is 1, 0, if we express it as a column vector, is the position vector of the point 1, 0. So right here I have the point, this would be 1, 0 right there. And this, of course, is the position vector of the point over 0, up 1. So if I was going to graph this point here, it would be 0, 1. Remember, position vector means our tail starts at 0. The implication of this is that the position vector of any point P, for example, there is P there, can be expressed as the sum of 2 vectors, one parallel to the x-axis and one parallel to the y-axis. If this vector is 1 unit over, then I can multiply whatever that is, 1 times x, and get my whole vector. If this unit represents 1, then I can multiply y by 1 and get the magnitude of that vector. I and j are also known as base vectors. I points in the positive x direction, always, and j points in the positive y direction, always. Here are 3 different vectors, A, B, and C. A in red, B in blue, and C in green. We can break the vector into its component vectors. Remember, we said we could break any vector into 2 different vectors. If we have a vector in 2D, 2 dimensions, it's flat on the board, we can break it into 2 different vectors, one parallel to the x-axis and one parallel to the y-axis. And again, that's in the vertical direction. We have J is our unit vector, and I is our unit vector in the horizontal direction. So if I have vector A, I could consider this going over 2 units in the horizontal direction and up 3 units. Of course, that would make this into a right triangle where Pythagorean's theorem would apply. That would be 2i plus 3j, or we could write it in column vector form, 2 over 3. Here I have vector B. It's going over 3i and down 3j. So that would be 3i minus 3j, or 3 over negative 3. Notice we're so used to doing slope, delta y over delta x, it's hard to transition to vectors which are x component or horizontal component over y component or vertical component. If I have vector C, I'm starting the tail here and going up this way. I have to go to the left or in the negative direction for the horizontal component, that's negative I, plus 3 units up. It's 3j, or in the column form we could say it's negative 1 over 3. Again, change in the horizontal component, change in the vertical component. Find a vector of length 10 units in the direction of 2i minus 3j plus k. Remember, if you're given I, J, and K, this is a unit vector in the x direction of 1, unit vector of 1 in the y direction, and unit vector of 1 in the z direction. So we're given a vector in 3D, and we're asked to find the length of vector length 10 units. Well, we know vector length 1 unit is the unit vector, and that's equal to our vector. Well, what is our vector? Our vector is 2i plus 3j plus k. So we already know 2i plus 3j plus k is our numerator. It's just the vector goes in the numerator. What's the denominator? Well, it's the magnitude of our vector, which we use with the Pythagorean theorem. 2 squared plus negative 3 squared plus 1k squared. I'll take the square root of that and I'll get the square root of 14. Well, if a unit vector is unit length 1 is equal to that, so I know that my unit vector is equal to 2i plus 3j plus k, all divided by the square root of 14. That's one unit vector in this direction of this vector. What about 10? Well, 10 means multiply that side by 10 and multiply this side by 10. So here is your answer. Here is a vector of unit 10 in length in the direction of 2i minus 3j plus k. It's a little unsatisfying, but it is the answer.